Alrighty, wonderful children. It's time for day 2 of 9.4. I just had some delicious tacos. It is Taco Thursday. Hopefully I don't have any cilantro in the teeth. All right, let's go for this. So first example, well, actually, let's go over our goals here. It's good to have goals. See if we meet those goals. So we want to compute vectors in component and INJ form, given our magnitude and our direction. That's going to be our first example there. And then algebraically solve application problems using the linear combination form. All right, let's do this. First one, find the component form. So that would be our, let me get a marker up here. That'd be our A comma B of the vector V given the magnitude being 10 and the direction being 225. Now, some of us are visual. Some of us like to go the algebraic approach. We're going to show you both. All right, or I'm going to show you both. All righty. So an angle of rotation of 225 would be all the way over here. That's 225. And then my magnitude's 10, so that's this guy right here. That's my hypotenuse of this eventual right triangle that I'm going to draw. Well, if it's 225, that means that we have ourselves a 45 reference. And if we remember our 45, 45, 90 triangles, I'm going to divide by root 2 and rationalize, which would give me 5 root 2 and 5 root 2. But it's going down, it's going to the left. So we have negative 5 root 2, negative 5 root 2. There is our vector V. Beautiful. Like it. Another option you can do is that A is going to be your R cosine theta, much like X is our R cosine theta, right? And then B would be our R sine theta. Now this, you could do it for one of these types of problems. That's totally fine. The other times this would be very helpful is when we don't have nice trig values, right? If we had something like, 200. That's a 20-degree reference. That's not something that's normal for us to deal with in nice trig. So it is definitely useful in certain problems, application especially. So let's go for this. Well, I would have A is R cosine theta, so that would be 10 times, and then cosine of 225 would be negative root 2 over 2. So that gives me my negative 5 root 2. And then our B would be the same thing. So we can see we have that right there. Beautiful. I love it. I love it. Fantastic. You know what I'm going to do here? There we go. I added in a little bit more work there. As you can see, we got 10 cosine 225 and 10 sine 225. I should have put that in the first place. But there we go. Awesome. Get the same thing either way, graphically, algebraically. Cool. Alrighty, now we've got two different vectors, 6, negative 2, and 2, 5, right, for our V and our W. We want to find the following. Now, we're doing the magnitudes added together, and then the resultant vector, take the magnitude of that. Those are two separate things. Let's talk about, or let's show that, and we can talk about why. So the magnitude of V, we've already done that. That'd be 6 squared plus negative 2 squared. Doesn't really matter. It's negative because it's going to turn positive. So I get the square root of 36 plus 4 is 40. So that's going to be 2 root 10. Now the magnitude of W, I got, let's see here, 2 squared plus 5 squared. And so that would be, let's see here, 4 plus 25, that's 29. And that'd be that. So the sum of those two is just 2 root 10 plus the square root of 29. That's it. Now with the other one, we need to add them together first. So I'm going to get V plus W. That's going to be 6 plus 2 is 8. And then negative 2 plus 5 is 3. And now I'm going to take the magnitude of that. So I'd have 8 squared plus 3 squared. So that's 64 plus 9, that's 73. Boom. Root 73 is our final answer. We can't simplify that. Now, let's think about y for just a sec here. Magnitude would be something like a length, a speed. So when we start doing application problems, we're going to see like an airplane going and then like say like a breeze that's like maybe coming to the side of it or whatever. So if you were to just add those two magnitudes together, you're going to get the combo of the speed of the airplane and the speed of the wind as if they're both like adding to each other, and then that's our overall speed. But that's not how it works, okay? So if you have like a side wind, it is pushing it along, but not its full speed. So you need to find your resultant vector first, and then you can find your magnitude of that to get the speed. So these are the individual magnitudes added together. This is the sum of the two vectors, the vectors added together, and then the magnitude of that. So they are two totally different things. Don't make that mistake. Whew. Now we got some graphs, a little bit true false. All right, so with these, it's very important to pay attention to the arrows, right? The direction that these are going, because the direction matters. One direction, favorite band. All right, true false is V plus W. Notice they're bold, so we don't need the little arrow over it. Equal to K. So if I go tip to tail, that's where they're connected, right? My vector should actually be going this away. So this would be false. Wrong direction. It's going the other direction, not one direction. Like Harry Styles, he went the other direction. See? Look at that. I connected it again. Awesome. Fantastic. I can't stop it. I can't help myself. All right. Next one. A plus B, is that equal to C? Well, we would actually need to use, in this case, because we have the, we don't have the tip to tail method going on here, do we? We're really actually set up more so for like our parallelogram method. So if I were to then pop A down here, and then B right here, this would be my resultant vector. So again, false. Use parallelogram method. Cool. All right, I like it. You could have also, brought B over. Let me do that in a different color. You could have just slid B over like this. Oops. And done your tip to tail method. In any event, you would still get C being that green one there, that solid green one, which is not what we had there. So false again. Bummer. 2 false in a row. That always worries you when you're taking a test. You're like, I have too many falses or too many trues. Am I wrong? All right. True or false? H plus F is equal to K. Well, this time we got our tip to tail going on, and we are connecting it correctly. It's the correct direction. True. So just a reminder, you've got your tail, and that is our start for this one. Then you got your tip, then you got your tail, tip. Beautiful. Tip to tail, and then we connect the tail and the tip. That's like a tongue twister, All righty. Couple more here. So why don't you pause the video? I'm going to probably pause it for you. And then see if you can get true or false for each one of these. All right, hopefully you're able to try each one of them. If not, you can still pause the video. We haven't gone over it yet. All right, let's go. So I'm going to go with, I'm going to go orange. All right. So K is equal to Z. So K is this one here. Z is this one here. They are both the same direction, same magnitude. True. Same direction, same magnitude. Nice. B, W equals H. W here is going in this direction. H is going the other direction. Although their magnitudes are the same, the direction is not. So false. Wrong direction. All right, how about V minus H is equal to K? So here's V. And remember, if we're doing minus H, that just means we're going the other direction with it. And if I were to take that, let's see if I can do that. Oh, come on, you technology. Boom. Look at that. Tip to tail method, that is K right there. That's money. That's money. That was cool. That was a technology flex right there. I'll tell you what. All right, next one. This one's going to get crazy. We got 4 things going on. V plus W. Okay, we're all set up for tip to tail. Don't need to move anything. And then minus P, so that's going to go the other direction. So now we're doing this. Sorry, the chair's a little squeaky here. And then plus H, so keeping it the same direction, gets back to the same point, which is why it is equal to 0. True. If that's weird, that's like, oh, we just came back to the same thing. It's just 0. Well, if you did like V minus V, it would, like undo itself, right? It'd be 0. right? Because it follows those same properties. So, and that would be getting you back to that start point. Okay, at least that's how I like to think of it. Lovely. Those are some good true-false questions. Let's go on to some application. I love application. So we got a kid pushes a lawnmower up a small ramp, which makes an angle of 25 degrees with the horizontal. The kid pushes on the handle of the lawnmower with a force of 50 pounds. Express the force vector F in terms of I hat, J hat. Ooh, we're missing a hat. Beep. Okay, so let's draw a picture first. So we got this angle of 25 degrees. So we're going to be using our calculators. Make sure you're in degree mode. Okay, make sure you are in degree mode. Meme time. Hold up. Is that calculator in degree or radian mode? There you go. Now we're good. All righty, so we're in degree mode, right? We got a force of 50 pounds. That is our magnitude. And what we're trying to find is our force vector in terms of I hat, J hat. So what we're going to do is we're going to create ourselves a nice little right triangle here. We've got our A value and our B, right? A and B. So let's figure this out. Well, I know that A is equal to R cosine theta and B is equal to R sine theta. Lovely. Bring it back. So let's see here. We've got A is equal to 50 cosine of 25, and B is equal to 50 sine of 25. Now we'll type that into our calculators, right? Stay strapped, TI-84. When we get to application, YORO, don't forget. And I already got it worked out off to the side here, so we're going to get A is equal to 45.32 pounds. That's a force in our horizontal direction. And then in our vertical direction, we've got 21.13 pounds. And it's helped to put that in the context, right? The A is in the horizontal direction, the B is in the vertical direction. And it makes sense that the force is higher in the horizontal because that angle is pretty mellow. But once you pass 45, now those values will switch as to where the force is greater, right? And it's nice to make sense of those things in your head and be like, okay, like why are the numbers like this? Did I make a mistake, right? So our force vector is going to then be 45.32 I hat plus 21.13 J hat. Woo woo! That's our force vector. I love it. Fantastic stuff. Wonderful, in fact. First application problem, done, in the books. Awesome. Alrighty, a little exploration, shall we? Love exploring with math. I always loved that, you know, when I got that in a math class, we're like, let's explore. It's like, no. But yes, let's do it. Alrighty, find a vector from its direction and magnitude. So a lot of applications, vectors are going to be described in terms of our magnitude and the direction rather than in that in the components, okay? So if a given magnitude and direction, or a magnitude and direction are given, how can a vector be expressed? All right, so we got a ball thrown with an initial speed of 90 miles per hour. What would that be considered? Well, if it's 90 miles per hour, the speed, that is my magnitude. All right, when the ball is released, the angle it makes with the horizontal is 30 degrees. Okay, that's going to be my direction here. So there we go. We got our nice graph below there, right? Now, to find the terminal point of the vector, we can use what we know about trig to find our x-coordinate and our y-coordinate, right? So if we were to draw this bad boy in here, so I got my A, got my B. Sorry guys, had a couple visitors there. Let me get back on track. So let's see here. We got cosine of 30. That would be equal to my adjacent, which is A over 90. So if I were to solve that, I'd get 90 cosine of 30. In other words, we're going to have our cosine going to be associated with our x coordinate. We'll call that alpha this time. And our y coordinate, we're going to be using our sine of alpha. Okay? So we could do the same there with b. Let me do that real quick. We could have sine of 30 is equal to b over 90 multiplied by 90. And I've got b solved, right? Always kind of nice to look back at the visual there and not just kind of memorize little pieces of the puzzle, right? Okay, so with that being said, let's pop down to number 3 now. Since this vector is a position vector, and remember, position vector is that initial point is at the origin, Okay, we're starting at the origin. Then its simplified form is going to be 90 times, let's see here, we got cosine of 30 I hat, and then sine of 30 j hat. Now, let's see if we can get rid of those, the sine and cosine there. So cosine of 30 is root 3 over 2, which would then, if you multiply that to 90, root 3 over 2 times 90 is going to be 45 root 3. And then sine of 30 is 1/2. Half of 90 is just 45. Oh, that's beautiful. That's wonderful. So we could multiply out 45 root 3. We'll leave it here for now just for ease. I think a lot of times in my math lab, they want you to put it in simplified radical, rather in simplified trig values rather than in decimal rounded. Honestly, in application, I think rounded decimals makes a little more sense, but we'll keep it clean for here. So of the initial speed, how much is in the horizontal direction? Well, remember, our horizontal is that A, right? That's with our cosine there, right? So that's the first one. So we have 45 root 3 miles per hour, right? It was miles per hour? Yep. In the horizontal direction, okay? Now, if we were to calculate that out, I've actually got it worked out over here in side work, 77.94 miles per hour. Okay. And then in the upward direction, right, in the vertical direction, we're just at 45 miles per hour. So when it goes off of that angle, you're not 90 in each direction. It's partially into that horizontal and partially into the vertical. And since we're not past that halfway point of 45, you know that the horizontal force is going to be more than the vertical one. All right, always check those things out. Helps. So let's generalize this here. Given the magnitude of a non-zero vector v and the direction being between 0 and 360 for alpha here, and the horizontal axis, right? This is off of our horizontal axis. That's important because sometimes when we get to navigation, we'll start from the north of a compass. So we got to pay attention to those things. Not that important right now, but once we get to compass, we will. Then I would have my magnitude times cosine of alpha I plus sine of alpha j. So there's our general form. Excellent. Wonderful. Cool. Woo. All righty. Feeling good? Feeling good? Make sure you rehydrate. Take a little break. Let's keep cruising. All right, so here's a nice little infographic. I'm pretty sure Miss Price found this bad boy, and I got to give her credit on it because I'm a big fan of it, okay? Big fan of this graphic. So if you have an airplane, okay, you may have, if you've ever been on a flight and they say, like, hey, it's actually going to be a longer flight than we anticipated. It's going to be an extra 20 minutes. Usually they don't tell you that, but they might. It could be due to a headwind, okay? So the velocity of the aircraft here is 150 kilometers per hour. There's a headwind of 30 kilometers per hour. Boom, now we're at a resultant vector of 120 kilometers per hour. Obviously, there's other things like drag and stuff like that go into it, but that's the basic math of it. Now, say you got a crosswind. Now, that's going to be pushing the aircraft to the side a little bit, so its path is going to be a little bit longer. So we'd have to end up using that tip-to-tail method there to get that resultant vector, and using Pythagorean theorem, now we can, well, using the magnitude there, which is Pythagorean theorem, we can get our resultant, or our magnitude there, which would be the 156. So I'm talking about. So that crosswind will throw it off. They have to adjust for that. Now, say you got yourself a nice little tailwind, right? That's when the person gets on there and they're like, hey, guess what? We're going to get to your destination like 20 minutes faster. You're like, woo, we must have a tailwind. Let me get some vectors going and I'll let you know. That's what's going on here. Add those two together. Boom. Right? And again, this is all like if it were to be exactly that. Obviously, there's other factors as well, which we'll talk about. Then say you have yourself like a little like a 30-degree angle or something like that. We actually used law of cosine, something that some of you've been exposed to, some of you have not. But again, we take that that crosswind, or sort of a crosswind, go in there, and we can still use that tip-to-tail method as it comes back, and then we can get our resultant that way. Nice. I like this graphic very much so. All righty. So we're in pretty much the basics of vectors right now, but there's all sorts of forces that you need to take into consideration here when using them. We're not going to deal with all of them, but like think about an airplane. You got your thrust, you got your drag of the airplane, you got your lift, you got gravity as well, right? Those are all sorts of things that are going into play there, not just the wind, right? There's a lot more than that. Say you're pushing an object up a ramp. How much friction do you have? That's working against you, right? Gravity's working against you. So you know that's all going to be affecting how much you need to put into it, right? It doesn't take just 50 pounds of force to move a 50-pound box. There's more to it than that, even across a flat surface, you know, because you got gravity working against you. Next thing we got are compass directions. Okay, so these are important if you don't know your compass directions. Never eat soggy waffles. I don't know why they told us that, but I've always remembered it. So that's your north, east, south, west. Never eat soggy waffles. All right. Then in between them, we've got our northeast, southeast, southwest, and northwest. That's 45 degrees. Okay, 45 degrees between them, right? Smack dab in the middle. That's what's implied when you say northeast. You're talking about 45 degrees off of the north, right? Northwest, 45 degrees the other way off of north, okay? So that's what's assumed there is this 45 degrees when they don't specify, okay? Now, if we start saying things like north, 30 degrees east, well, now you're looking more like this, north, 30 degrees east. So that would be a 30-degree angle right here, which then for trig, and this is where things get a little bit tricky, this would be a 60-degree trig angle, right? So if I want to use trig, I need to be using angles that are off of the positive x-axis. So when we're dealing with directions, once we want to math it up with those, we need to convert them to trig-friendly values, and then potentially for our final answer, move them back into your navigation, depending on how the answer is, how it's being asked for, okay? So feel free to screenshot. Let me get this stuff out of your way if you haven't done so already. Boom, there's our directions. So let's do a little bit of compass reading here. So north, 40 degrees east. Almost did that one just a second ago. North, 40 degrees east. If I go 40 degrees off of the north line there, this is north. Whoop. Boom, that's 40 degrees east right there. That'd be my compass reading. Now, if I wanted to get my trig, that's going to be a 50-degree angle of rotation if I'm using it to calculate. Had a visitor, briefly. Had to strap up. All right, cool. Now, north, 10 degrees west. So 10 degrees west, again, starting from the north, I'm going to move 10 degrees west. That would be north 10 degrees west. Now my trig, now I'm going 90 plus 10. That is going to be 100 degrees if I'm using it for trig value or trig calculations, right? Okay. Next one here. South 15 degrees west. So here's my north. This is my south. To the west, there's west. This would be 15 degrees off of south. So what's my trig value then? Well, for my trig measure, I've got 90, 180, and then I got to continue another, what would that be? 75. So that's 180, oops. Plus 75, that's 255. So if I'm doing any calculations, that's what I'd be using in my calculator with that cosine and that sine to help me figure things out. Cool. So knowing how to draw those out, what that looks like, important. Being able to convert it into your trig-friendly numbers, that's important too. Let's keep moving. All righty, so we got ourselves a nice little example here. A Boeing 737 jumbo jet can maintain an airspeed of 550 miles per hour in still air, okay, meaning no air, in a vacuum of space. We wouldn't want that, actually. Suppose the jet is headed in a southwesterly direction, meaning southwest, so that's that 45-degree, right? The velocity of the prevailing wind is a constant 100 miles per hour from the west, so it's blowing from the west to the east. Find the actual speed and direction of the aircraft. Okay, let's sketch this thing to get a general picture of what's going on. I'll go purple this time. So if I got myself this, my jet is going in the southwest direction, right? So this is west, this is south. So this is the jet, right? Now there's that other, and I'm actually going to go with a different color here when we're graphing it. So that's the jet, right? The velocity of the aircraft. We'll put an A there. Now the wind is going from the west, okay? And then this was 550, right? There we go. And then, so from the west means it's going from west to east. So this is the velocity of the wind. We'll do a W equals 100. There we go. All right. So it's going from the west to the east. That's, you got to be careful with reading that. So we got the graph of the situation in order to express the two of those, okay? And we want to use vectors in I hat, J hat, I and J. So let's do that. So the velocity of the aircraft, I'll start with that one. So I'd have 550 cosine of 225. How did I get 225? I took the southwest, which is 45, off of that west compass direction there. So that's 180 plus 45. There we go, 225. All right. Plus 550 sine 225. My goodness, I almost forgot my I hat, J hat. Whee! There we go. Cool. So that's the velocity of the aircraft. Let's do the same thing for the velocity of the wind. So we'd have, in this case, remember it was 100 was our speed there. So we cosine of, well, that's a 0 degree rotation, right? So cosine of 0, I hat, plus 100 sine of 0, J hat. Cool. Now, in this next part, because that was all this asked for here. Okay, just the speed of the velocity of the aircraft and the velocity of the wind. Look at the next one. It says find the velocity of the relative to the ground. In other words, find the resultant vector. So we're going to take these two, add them together. Okay? So we add those two together. I think what we might want to do first is actually let's evaluate our trig values. So cosine of 225, that is negative root 2 over 2, and same with sine of 225, right? So I'll go with velocity of the aircraft is equal to 550 times root 2 over 2. I'm just going to jump ahead, and that's going to be what? 275 root 2 I hat. And then we have plus, and then again, negative root 2 over 2, 550 over 2 is again 275 root 2. So this is negative and negative. My apologies there, both those negative. I had J hat. Okay. Now let's go with our velocity of the wind. So cosine of 0 is 1, right? So that's 100 I minus, and then sine of 0 is just 0, so 0 J hat. Okay, so we've got our 2 there. And to get our resultant vector, we need to just add those 2 together. All right, so we'd have, if we add these 2 together, we would have negative 275 root 2 plus 100 I hat, or we could do 100 minus 275 if you don't like that negative out in front. And I kind of don't, so that's why I'm going to do that, because I'm the one doing this right now. And then I'd have minus 275 root 2 J hat. So that is velocity relative to the ground, exact answer. And I believe that's how they want you to enter things into my math lab for this one. But we can also get an approximate value by plugging those into our calculator, okay? So we have this, this vector for our aircraft, the velocity relative to the ground. Now what it's asking for is the actual speed and the direction of the jet relative to the ground, okay? So how do we do that again? We've done so many crazy numbers here that it can be easy to get lost, right, as to what's going on. Well, I'm going to do this. I'm going to pull up the calculator here real quick. I'm going to plug these in and get some actual, like some rounded value, not rounded, but some stored values. So that minus 275 root 2. So I get a decimal value. Oh, forgot to close my parentheses. It's okay. And then I'm going to store that for A, right? And that makes sense because that would be like the A part of my vector in component form. Okay, I'm going to do the same for the other part there. So negative 275 root 2. I'll close it this time to be classy. And then I'm going to store that. So store alpha, and I'll do B. Nice and organized. Good stuff. I got A and B stored. Okay? Love that feature. All right. Now it says find it relative to the ground. So if we got roughly negative 288.9 and negative 388.9, where would that be? That would be still in my third quadrant, right? So how am I going to find my speed? Well, the speed is just the magnitude, right? Let's pop up that calculator. That's just some Pythagorean theorem inside that square root. Boom. And then I can go alpha. Oh, this is so cool. A squared. Boom. B squared. Close it. Boom. 484.48. Miles per hour. That's my actual speed. Now the direction, how do we find a direction? Direction would be inverse tangent of the opposite over the adjacent. We're going to finish that up, and then Mr. Allen, got it, go. All right, tangent inverse of my opposite side is the B divided by alpha, A, boom, 53.39 degrees. That's off of that axis, so I would need to add 180 to that to get my trig direction. Okay, so 233.39. Or we said this angle was 53 point something, right? 53.39. So that's not a compass direction, but if I were to say get this, if I did 90 minus that, 90 minus that 53.39, that would give me this angle right here. Okay, let's do that real quick. So 90 minus 53.39, and boom, that's 36.61. Why is that important? Well, I could say south 36.61 degrees west for my direction. That's why I did that. All right, that was a lot. I'm out of time here, so I'm going to cut the video off at this point. I am going to do 2 more examples in a bonus video because these problems are quite a bit, and that you might want to watch a couple more of those, but I'm going to make that a separate video with 2 more application problems that'll just, you're probably looking forward to it already. So have a wonderful day. America, freedom, rock and roll, Costco. Don't forget YORO, right? Don't be rounding these values. I know we did that here, but that didn't affect it because we were just subtracting. We weren't doing any other calculations with it. That was awesome. I hope you guys enjoyed. See ya.